Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem vertical sum. Previously, this problem has been asked in Amazon. So let us read this problem statement and see how we can implement it in terms of code. So the problem says that we'll be given a binary tree which will be having n nodes and we have to find the vertical sum of the nodes that are in same vertical line. So we have to return the sum of all the different vertical lines starting from the leftmost vertical line to the rightmost vertical line. Now, what is vertical sum? So vertical sum is basically when you are taking the sum in this particular direction. Okay, when you are taking the sum from top to down, or you can say in this direction, then that is known as vertical sum. Okay, because these are vertical lines. Now, suppose if we have got a tree, let's say we have got the tree as what? Let's say we have got 1 here. Then after that we have got the node 2 here. Then we have got what? 3 here. Then after that we have got 4 here. Then we have got 5 here. Then we have got 6 here. Then we have got 7 here. Okay, if this is the case, so let me draw a number line now in order to understand better. So let's say I'm drawing a number line which is basically the x-axis. Now on this x-axis, if you'll see, so initially if you see, let's say I'm considering the root guy as what? Let's say if I'm at the root guy, so I'm considering it as 0. Okay, for the root guy I'll consider its x-axis as 0. Okay, if I go on the right, then I will increase the x-axis by 1. If I go on the left, so I'll decrease the x-axis by 1. So for 3, the x-axis will be what? 1. Okay, then with respect to 3, if I go on the right, so the value will be 2. With respect to 3, if I go on the left, so the value will be 0. Okay, then for 1, if I go on the left, so the value will be -1. The axis value will be -1. If I go on the right of 2, then the value will be 0. Okay, if I go on the left of 2, so the value of x-axis will be -2 here. Okay, so if you will see here, guys, the thing is that this is the axis 0. Okay, this axis is basically 1 and this axis is basically 2. Okay, here the x-axis is -1 and here the x-axis is -2. Now what is the sum of all the nodes on the axis? That is -2. Okay, on the axis -2, what is the sum? So the sum is basically 4. Okay, because there is only one node, so you can say that on the axis -2, you can say if I take a map, so for -2 the sum is how much? Only 4. Then how many nodes are there on the axis -1? When x value is -1, then there is only one node. So you can say that with respect to -1, there is only one node. So you will have what? You will have the sum as 2 only. Then with respect to 0, you can see that when the x-axis value is 0, so the node is 1, 5 and 6. Okay, so whenever I'll be like, so I need to take a map, and with respect to 0, whenever the x-axis is 0, so whatever node values are there or whatever node data are there, I will add them in my map. Okay, with respect to 0. So 1 plus 5 plus 6 will be how much? This will be 12. Okay, then next time when the axis is 1, then there's only one node 3, so the sum will be 3 only. Then when the axis is what? 2, then the sum will be how much? Only one node, so 7. So you can see here that what I have here, what I've got here is I've got 4, then 2, then what? 12, then 3, and then what? 7 here. Okay, so these are the sums that I've got, because for the x-axis -2, the vertical sum is what? 4. For the x-axis -1, the vertical sum is how much? 2. For the x-axis 0, the vertical sum is how much? Total vertical sum is basically 1 plus 5 plus 6, that is 12. Then for the x-axis as 1, the sum is 3. For the x-axis as 2, the sum is 7. Let's cross verify and check. So if you will see here, we have got the sum as what? We have got 4, 2, 12, 3 and 7. So I've got the same sum 4, 2, 12, 3 and 7. So I need the keys in sorted order as well, because these are the keys, and I've got 4, then 2, then 12, then 3 and 7. So my keys are what? -2, -1, 0, 1 and 2. These are the x-axis that I've got, and how I can keep these keys or the x-axis in sorted order. So for that I need an order map, or I need a normal map. Okay, so you can see here that whenever I'll be calling for a particular x-axis, so at that particular x-axis, whatever is the node value, I will add it and I'll update it in my map. Okay, so we can do it by using BFS as well as DFS, but for this question I'll be doing it using, let's say, a recursive approach or the DFS approach. Okay, so what I will first of all do here is I will be first of all declaring an unordered map here. So let's declare unordered map. Sorry, let's declare a map here which will be storing the sum. So I'll declare a map, let's say int comma int. It will be storing the with respect to a particular axis, what is the vertical sum. It will be storing this particular data. Now after this, I also need a vector int answer. Why I need an answer? Because I have to return all the sums at the end of the day, so I need an answer for that. Now what I will do here is I'll initially start with my recursion. Okay, and I will pass my root node first of all, then I will pass my map, and initially my x-axis is what? Initially my x-axis is nothing but 0, because I'm starting from the x-axis 0. If I go on the left, so my x-axis will decrease by 1. If I go on the right, so my x-axis will increase by 1. Okay, then after this, what I will do is, when I'm writing this recursive call, so we can write it as, let's say, void recursion. Okay, and then what we can do here is, we can write node star root here. Okay, and then we can write a map of int comma int ampersand mp. Then after that, what we can do is, we can write here int the x-axis. Okay, now after this, what we will do is, suppose that if we reach a particular root which is null, so that is when we have to stop our process here. So we'll directly return away from there. Otherwise, what we will do is, we will say that whichever node we are at, so we will say that whichever node we are at, okay, whichever x-axis we are at, okay, so whatever is the node data as of now, we'll update it. So we'll say that with respect to this x-axis, whatever is the sum already stored inside the map, we will add it with the current node value. So we'll add it with the current root data here. Okay, we'll add it with the current root data, and once that is done, so we will do what? We'll call the recursion for the left as well as the right. So we'll call for the roots left. Okay, and when we are calling for the left, so we'll pass the x-axis as x minus 1. Okay, because going on the left, x-axis will decrease by 1. Then we'll call the recursion, and we'll pass the root, and we'll call for the right guy. Then we'll pass the map, and then we will do x plus 1 here. Okay, and once this part is done, so my map will be ready. Now what do I want to store? Do I want to store the x-axis, or I want to store the sum? So actually I want to store the sum. So if I want to store the sum, so it is basically the value. Okay, I want to store all the values here. So I want to store what? I want to store the second part of the map. The first part of the map is key. The second part of the map is what? The values. So in Java I will store values, and in C++ I can say that I'll store the second part of the map, that is the values, because I want to store the sum 4, then 2, then 12, then 3, and then 7 in this order from left to right. Because why left to right? Because the leftmost x-axis is -2, the rightmost x-axis is +2. So that is why, in order to keep the keys in sorted format, I have done what? I've used a normal map here. So let's implement this further. So what I will do here is, I will basically iterate, and I will say that for, let's say, auto, let's say it is to map. So I'll basically iterate in this map, and I will store the second part. Okay, so one by one, for all the keys, I will get the sum, and the keys will be sorted in ascending order. So the leftmost key will be first there. So the leftmost x-axis sum will be stored, then next, and then next, and lastly I'll store the sum of the last x-axis. Okay, so that is how I'll store the vertical sum from the leftmost vertical line to the rightmost vertical line. So what I will do here is, I'll say that in this case, I'll push inside my answer, I'll push what? it.second. So I'll push the second part of the map, and once that is done, so we can simply do what? We can simply return our answer array here. Okay, so let's try and run this code to check if it is working fine on the samples or not. It should ideally work fine on the samples. So let's check. It is currently running, because I guess the server is a bit slow, or maybe the internet is slow. Let's check. Okay, so it is still taking a bit of time. So in the meantime, let's try and submit it. I guess it should get accepted only. Okay, so it is running fine on the samples. Now it is getting submitted. So you can see that my code was able to pass all the test cases. So basically the idea is very simple and straightforward, that you can get the vertical sums by using the concept of x-axis. Initially you can say that the root will be at the x-axis 0. If you are going on the left, so you'll do current x-axis -1. If you are going on the right, so the x-axis will be current x-axis +1. Okay, and with respect to whatever x-axis you are at, okay, you will keep on updating the node datas for all the x-axis. That is how you will update your vertical sums. And then my map is storing the vertical sum from the leftmost vertical line to the rightmost, because I'm storing the x-axis -2 first of all, then +2 later on, because the keys are in sorted order in this particular map. So I'm storing all the sums one by one in my answer, and then I'm pushing it. So I hope that you have understood this problem clearly. In case if you did, make sure to comment understood or clear in the chat. Thank you for watching this video, guys.